U.S. finally tests insane A-10 Warthog. Revving up the engines of power and precision, the long-awaited moment has arrived as the United States puts the insane A-10 Warthog to the ultimate test. Brace yourself for an awe-inspiring display of unrivaled combat capabilities and unyielding strength. Join us as we witness the epic culmination of years of anticipation as the mighty A-10 Warthog takes flight, ready to redefine the very essence of air superiority. The A-10 Thunderbolt is a dual-engine aircraft designed for close air support, which is produced by Fairchild Republic, presently a subsidiary of Northrop Grumman, and utilized by the United States Air Force. The aircraft, commonly referred to as the Warthog, the Flying Gun, and the Tank Buster, was utilized to a significant extent during Operation Desert Storm in conjunction with NATO operations in reaction to the Kosovo crisis and in operations Enduring Freedom and Iraqi Freedom. The A-10 is a military aircraft that boasts high survivability and versatility and is favored by pilots for its effectiveness in ensuring a safe return to base. The primary objective of the aircraft is to conduct ground attacks against tanks, armored vehicles, and installations, in addition to providing close air support to ground forces. The United States Air Force, Air Combat Command, Air Force Reserve, and Air National Guard collectively operate 281 A-10 aircraft. The United States Air Force is currently utilizing various aircraft variants, including the A-10 and A-10C, as well as Reserve A-10 and OA-10, and ANG A-10 and OA-10. In December 2022, the National Defense Authorization Act, or NDAA, for fiscal year 2023 was approved by the U.S. Congress, which included the USAF's proposal for a planned divestment of the A-10 aircraft. The decision was made subsequent to several unsuccessful endeavors by the United States Air Force to decommission the A-10, which were impeded by Congress. The United States Air Force holds the perspective that the maintenance of aging aircraft presents significant challenges, and has thus made the decision to allocate funds originally intended for maintenance and upkeep towards the acquisition of contemporary aircraft. So let's talk about the specifics of the development of the A-10 Thunderbolt. In May of 1972, the inaugural flight of the A-10 took place, and subsequently, a grand total of 713 aircraft were manufactured. The manufacturing of the A-10 aircraft was terminated in the year of 1984. The A-10 aircraft was initially produced by Fairchild Republic, a company that is currently a subsidiary of Northrop Grumman. Since 1987, Northrop Grumman has served as the primary contractor for the A-10. The Integrated Systems and Aerostructures divisions, located in Bethpage, New York, and St. Augustine, Florida, have been executing support and structural upgrade initiatives at Northrop Grumman. The A-10A and A-10C attained their respective initial operating capabilities in 1977 and 2007. In June 2007, Boeing was granted a contract worth $2 billion for the A-10 Wing Replacement Initiative. In September 2013, the United States Air Force opted to procure 56 replacement wings, thereby augmenting the overall count of aircraft within the program to 173. In August 2019, the final 173 aircraft underwent wing installation at Hill Air Force Base in Utah. The recently developed wings exhibit improved strength and effectiveness. Boeing was granted 2 contracts by the USAF in September of 2009, totaling $4.2 million, to undertake the modernization of its fleet of 365 A-10 Thunderbolt II aircraft. The project was slated to span a duration of 3 to 18 months. The aforementioned agreement was granted in conjunction with the comprehensive TLPS contract, which amounts to a total of $1.6 billion and pertains to the lifecycle program support of the A-10 Thunderbolt. The initial agreement encompassed the A-10 Aircraft Structural Integrity Program, also known as ASIP, entailing the delivery of engineering services for the aforementioned aircraft. Conducted by Boeing and Southwest Research Institute, the study aimed to modernize and harmonize contemporary structural analysis tools, procedures, and criteria for the A-10 aircraft group. The subsequent agreement encompassed an evaluation of trade studies and an operational assessment, including a proof of concept for the Enhanced Data Transfer Unit. The contract was executed by Boeing, Raytheon Technical Services, and BAE Systems Platform Solutions, with the objective of enhancing the avionics architecture of the aircraft to augment its memory and data capability. In August 2019, the United States Air Force awarded Boeing a contract valued at $999 million for the purpose of providing sustainment services on the A-10 Thunderbolt II aircraft. Under the 11-year agreement, the task at hand entails overseeing the production of 112 novel A-10 wing assemblies and 15 wing kits. Under the contract, Boeing collaborated with Korean aerospace industries and other essential suppliers to provide services. The initial wing assembly stipulated in the agreement was conveyed in May of the year 2022. In October 2019, CPI Aerostructures was chosen by Boeing to supply structural assemblies for the wing replacement initiative of the A-10 aircraft. In November 2019, Cayman Aerospace Group was awarded a contract by Boeing to produce wing control surfaces and structural assemblies for the A-10 re-winging initiative. The scope of the contract encompasses the provision of inboard and outboard flaps, slats, and deceleron/speed brake assemblies, which comprise speed brakes, trim tabs, and edge assemblies. Under a previous contractual agreement for the Wing Replacement Initiative, the aforementioned organization provided flight control surfaces to Boeing for a total of 173 aircraft. In August 2020, the United States Air Force awarded a contract worth $1 million to the Southwest Research Institute and Saberliner Aviation for the purpose of conducting ongoing structural analysis and maintenance of the A-10 Thunderbolt II aircraft fleet. In June 2022, Raytheon Intelligence and Space, a subsidiary of Raytheon Technologies, was awarded a project-level agreement worth $46.2 million to upgrade the A-10. The corporation intends to substitute the present mission computer of the aircraft with its common open secure mission computer. This upgrade will furnish the aircraft's combat and weapons systems with improved processing capabilities, thereby facilitating the attainment of air dominance and sustainability. RINS has been chosen for the initial stage of a prototype project that comprises multiple phases. It is anticipated that a contract may be granted to RINS for the manufacturing and deployment of the Common Open Secure Mission Computer, also known as COSMIC. In October of 2019, Terma North America was awarded a contract worth $60 million to provide a novel 3D audio system for the A-10 aircraft that is currently operational with the ANG, Air Force Reserve Command, and ACC. The contract, which encompasses the provision, implementation, and maintenance of the Terma Aircraft Audio Management System, featuring the Terma 3D Audio and Active Noise Reduction System, is anticipated to be finalized by 2024. The AAMS is set to replace the outdated audio management system. The system has the capability to offer auditory alerts and prompts as well as radio communications to the pilot in a comprehensive 360-degree spherical format with the aim of augmenting situational awareness and mitigating stress. In February 2022, a test was conducted near Eglin Air Force Base, Florida, wherein a small-diameter bomb was carried by an A-10C Thunderbolt II. The A-10C Precision Engagement Upgrade Program is a modernization initiative aimed at enhancing the capabilities of the A-10C aircraft. The A-10's Precision Engagement Upgrade Program involves improved precision target engagement capabilities that facilitate the use of precision weapons, such as Joint Direct Attack Munition and Wind-Corrected Munitions Dispenser. Additionally, this upgrade program extends the aircraft's service life until 2028. Enhancements comprise of hands-on throttle and stick control, two novel Raytheon technical services 5x5-inch malfunction cockpit displays, situational awareness data links, digital stores management system, an integrated flight and fire control computer sourced from BAE Systems, platform solutions for automated continuously computed weapons delivery, Sniper XR or Lightning targeting pods for precision-guided weapons, and a helmet-mounted sighting system. The program was led by Lockheed Martin Systems Integration Owego as the primary contractor. In January 2005, the inaugural flight of the enhanced A-10C was conducted. In March 2005, a contract was granted for the low-rate initial production of 72 units. The inaugural unit was furnished to the Baltimore Air National Guard in August of 2006. In August 2006, a contractual agreement was made for the complete production of 107 units. In August 2007, the A-10C successfully attained its initial operating capability. As of January 2008, a cumulative of over 100 A-10 aircrafts had undergone upgrades. The A-10C was operationally deployed in Iraq in September 2007. The contract facilitated the upgrade of 356 A-10 aircraft. The integration of the Sniper XR targeting pod on the A-10 was contracted to Lockheed Martin in February 2004 as a component of the PE program. The Sniper XR system is equipped with a range of advanced technologies such as midway FLIR or forward-looking infrared, dual-mode laser, CCD TV, laser spot tracker, and IR marker. The present study concerns the mission capabilities of the A-10 aircraft. The A-10 possesses the ability to operate from forward air bases owing to its short takeoff and landing capability. The aircraft exhibits a considerable range and endurance, enabling it to sustain prolonged presence within the combat zone. It has the ability to land and function in harsh and challenging environments, the ability to navigate with precision and effectiveness at low speeds and altitudes, specifically below 1,000 feet, while maintaining a visibility range of 2.4 kilometers, enables the delivery of weapons with accuracy across diverse terrain categories. The study focuses on the intricate details of the cockpit of the A-10 Thunderbolt aircraft. The cockpit, that's designed for a single occupant, is fortified with comprehensive armor, featuring a titanium structure that encompasses the pilot in a bathtub-like enclosure up to 3.8 centimeters in thickness, providing optimal protection. The cockpit is equipped with a spacious, bullet-resistant bubble canopy that provides excellent panoramic visibility. The cockpit is outfitted with a head-up display that serves the purpose of targeting and weapon aiming, a have-quick secure radio communication system, inertial navigation, and a tactical air navigation system. The A-10 aircraft underwent an upgrade that involved the incorporation of the embedded global positioning system and inertial navigation system technology, which enables precise determination of the aircraft's location. The aforementioned equipment is equipped with terrain profile matching systems developed by BAE Systems. The pilot's outfitted with nocturnal visual aids in the form of night vision goggles and the Maverick AGM-65's infrared imaging display. The A-10 aircraft is equipped with 11 store pylons which enable it to carry external loads up to 7,260 kilograms. The aircraft's fuselage is equipped with 3 pylons which can be utilized to support loads. The loads can be arranged to be supported by either the central pylon or the 2 adjacent fuselage pylons. The aircraft has the capability to be equipped with PAVE penny laser guidance and electronic support measures for weapon guidance, which can be installed via a pod on the starboard fuselage pylon. The aircraft's wings are equipped with a total of 4 store pylons, with 3 located outboard and 1 located inboard of the wheel fairing. The A-10 aircraft has the capacity to transport a maximum of 10 air-to-surface missiles of the Maverick type. The Raytheon Maverick AGM-65 missile incorporates diverse guidance systems such as imaging infrared guidance and warheads that feature a conical-shaped charge warhead weighing 57 kilograms, known for its high penetration capabilities. The distance covered exceeds 45 kilometers. In addition to its primary functions, the aircraft has the capability to transport the Sidewinder air-to-air missile, a short-range missile that can be utilized from any direction and has a maximum velocity surpassing Mach 2, as well as 2.75-inch rockets. The A-10 aircraft exhibits the ability to effectively utilize a diverse array of ordnance, including, but not limited to, the LDGP Mk-82 226 kg, the 900 kg Mk-84 series low and high drag bombs, 226 kg general purpose bombs, BLU-1 and BLU-27B Rock I-2 cluster bombs, cluster bomb unit CBU 5271, combined FX munitions, and mine dispensing munitions. In addition to its primary functions, the aircraft has the capability to transport laser-guided, electro-optically guided bombs, infrared countermeasure flares, electronic countermeasure chaff, illumination flares, and jammer pods. The integration of the Northrop Grumman Lightning ER, or Extended Range Targeting Pod, onto the A-10 has been accomplished with success. The Lightning ER is equipped with a thermal imager of 640 by 512 pixels, a CCD TV, a laser spot tracker and rangefinder, an IR marker, and a laser designator. The airplane is equipped with a General Dynamics GAU-8A Avenger 30mm cannon that is situated in the frontal section of the aircraft. The A-10 is capable of incapacitating a primary battle tank from a distance exceeding 6,500 meters by utilizing its cannon. The cannon has the capability to discharge a variety of projectiles, such as armor-penetrating incendiary rounds with a maximum weight of 3/4 of a kilogram, or depleted uranium of 0.43 kilogram API rounds. The periodical has a capacity to contain up to 1,350 units of ammunition. The pilot has the option to choose between 2 firing rates, namely 2,100 or 4,200 rounds per minute. The General Electric Supply TF-34 GE 100 turbofan engines devoid of afterburning capability, deliver 9,065 pounds of thrust individually. The engines are situated in a high position on the fuselage, thereby enabling the pilot to operate the aircraft even in the event of one engine being non-functional. The aircraft exhibits a typical operational distance of 800 miles and a maximum velocity of 420 miles per hour. The maximum altitude attainable by the subject in question is 45,000 feet. And that's all for today's video, but we'll be right back with more soon. So please don't forget to give this video a big thumbs up and subscribe to our channel, and thanks for watching.